analyse the temperature outcomes from different emission scenarios and what level of global warming we can expect from a particular emissions set scenario or policy. I'm probably part of the first generation that grew up knowing about climate change and environmental degradation, and I always wanted to do something about that. I started working with Professor Piers Forster on climate modelling, and that's how I got into producing climate projections and developing this model. There's definitely real policy interest in using tools like FAIR to produce climate scenarios for the near future and longer term. So the FAIR model was first developed during my NERC-funded postdoc. It's a collaboration between Leeds and Oxford universities. Oxford did a lot of good work on the carbon cycle side, and we did the rest of it, so how air pollutants and other greenhouse gases affect climate change. And I think it's been a very successful collaboration. FAIR is what's known as an emulator. It's a set of equations that reproduce what happens in the global mean. So when we're given an emissions pathway, we want to be able to produce that scenario within a few minutes, and then we can actually go and report those results in a timely fashion. FAIR climate models has been used by our group and numerous other groups around the world. One sort of really interesting application was the US social cost of carbon. So this goes right to the top of US policymaking. It was also used in the IPCC mitigation report to produce the temperature outcomes from about 2,000 different emission scenarios. So one thing that we've used it for is to look at the climate benefits of a rapid phase out of methane emissions.
This work is really important for the IPCC to deliver robust information on climate change that can support policy, particularly in the context of the Paris Agreement. And their work builds directly on process understanding. So that means we can assess future temperature changes, changes in ocean heat content, sea level rise. It's an incredibly important tool to understand the spread of future projections that complex climate models produce.
There's definitely real policy interest in using tools like FAIR to produce climate scenarios for the near future and longer term. And I really enjoy making an impact in that sense and translating this work to policymakers.